Okay, let's consider problem 410. Okay, this problem is pretty long, and I'm trying to give you an idea of what I might expect for exams. So let's cut this back a little bit. Let's only find the, the side UT, and let's not worry about. Let's remove the area part from the problem. Okay. All right, so let's look at what we're given. We're given a plot of land, okay, but we can't measure one of the sides directly because there's an obstruction. It says to see figure 4.11. So let me draw that in separately. Okay, so here's the figure. Oops. Okay, we have a point R going to a point S, going to a point T, going to a point U, and the water obstruction is here. Okay. All right, so what we're looking for is this length, UT. Okay, and what we know is RU. Okay, so that's 121. And we know RS. That's 116. Okay, we know ST is 83.5. Okay, and we know the angle RST, so I'm moving from R to S to T. This angle right here is 113 degrees. Okay. We also know that the angle RUT, from R to U to T, is 82 degrees. Okay. So, if we're following the form, we know that we need to write down these givens. All right, we have the picture. So we're repeating these. I know it feels redundant, but this is part of the point I'm trying to drive home. So we know RU is 121. Okay, we know ST is 83.5. We know RST, the angle, is 113. And we know that RS is 116. Okay, so we're trying to get to UT, all right? And so we're looking at this, and it doesn't look like a triangle, but we need to form a triangle so that we can use trig properties to solve for the distance that we're looking for. So if I sketch in a dotted line here, all right, I can start thinking about the two triangles. Okay, so let's highlight this first one in green. Okay, so if we were looking at this green triangle, what do we know? We know two sides and an angle. Okay, so doesn't that set us up pretty well for the law of cosines? Okay, it in fact does. And so from there, we should be able to use the law of cosines to get this distance across. All right. All right, so if we know that, then we'll know an angle and two sides, and so we can use the law of cosines yet again to get the unknown side. So you see we're mapping out a path. We're using two different triangles. Okay, the blue triangle we don't know enough information about, right? With the blue triangle, we don't know UT and we don't know RT, right? So we use the information from the green triangle to solve for RT, then we have enough information to solve for UT. That's the path to the solution. So we're going to use the law of cosines. Okay. Right. So the law of cosines, if you need to, you have to draw it back out. So here's a triangle. We have A, B, and C. If you remember, the angle C goes across from the letter C. The angle B goes across from the letter B. The angle A goes across from A. Okay, so if I wanted to get C squared, it's A squared plus B squared minus 2AB cosine of angle C. All right, so that's law of cosines. All right, how does that apply for the upward triangle? Well, it looks like the role of A is played by R and S. Okay, the role of B is played by S and T. Okay, and we have the angle C being RST. Okay, so that lets us, write all this down, and so we can say that, give me some space here, RT squared, that's the role of A, is equal to RS, I'm sorry, RT is the role of C, the long side. Okay, RT squared is RS squared plus ST squared minus 2 RS ST cosine of the angle RST. Okay. At this point, we can actually plug in these numbers. Okay, we know what RS is. Okay, so we can plug in 116. We know what ST is, so we can plug in 83.5. Cosine of 113 degrees. Okay. Plug those numbers into your calculator and we get 167 point. What happened there? 167.32. Right, everything's been in meters, so this continues to be meters. Okay. That's, taking the root at the end to get the value of RT. Okay, so I put a box around that, but that's an intermediate step. Okay, next I go to the blue triangle and I realize I have the long side. Okay, so I have RT squared. Okay, that's going to be equal to 121 squared, the side that I know, plus UT squared, the unknown side, minus 2 121 UT cosine of 82 degrees. Okay. All right, so that's great because we know what RT is now at this point. That was the key step. We had to do that extra step to get that long side. Okay, so now we look at this and we think, well, how do I solve this equation? And you see, it's a quadratic equation. We move everything to the other side. We gather up all the constant terms. Okay, so that would be 121 squared. And then we get this minus 2 times, that says 112, but it's really 121 times, oh, that's not a constant, I'm sorry, 121 squared, where's that, minus the 167. Okay, so we have that constant, this constant. Okay, it looks like the only constants. Then we have minus 2 times 121 times ut times cosine 82 degrees, right? And then we have the plus ut squared. So the trick in engineering is to recognize things that you should know. You should know the quadratic equation. Okay, so when I plug these things in the calculator, I get a quadratic equation. I get ut squared. Then I get minus, when I plug in these numbers, 33.68 ut minus 14,473.7, depending on how many decimal places you carry. But that's a quadratic equation. Okay, so from there, you're supposed to remember the solution of the quadratic equation. So it'd be, this is the role of A. A is a 1. B is minus 33.68, and C is minus 14,423.7. Okay, so that's the B, and that's the C. We plug into the quadratic equation. And we know that, okay? That would give us the roots, okay? That would give us the values for ut, okay? So I'm not going to do that, but you can plug that in, and when you do, I get answers of minus 99.94 and 133.62. Okay, so there's two answers here, of course, because it came from a quadratic equation. One of these doesn't make any physical sense, and so we would omit the negative answer and keep just the positive answer. Okay, but then, of course, we're going to use the correct number of significant digits, and it looks like we, in this problem statement, we're looking at either 2 or 3 significant digits. It depends on what they mean by this 82. It does say just 82, but the others have fraction. I'd be a little more specific about it on an exam. Let's go with 2 significant places, and that would be 130 meters. Okay, so hopefully you'll see, it's a complicated problem. This is probably harder than most, but it's not unreasonable to expect something like this on an exam where you have to just piece through it and solve the equations. Okay, so there's a solution to 4.10.